In this video, you will learn how to graph quadratic functions in standard form. Be sure that you've watched the previous video on axis of symmetry and vertex. So for example number 5, we're going to have y plus 4x minus 2 equals negative x squared minus 7. This is actually the same as number 1. So let's make a note that we're going to see our work for number 1, because when we graph, we're going to do the same process as we've done before. We need to get this in standard form, so solve for y. Be sure to line up your like terms. So the 4x's cancel, the 2's cancel. We have y on the left-hand side. And then, of course, make sure you put these terms in the correct order. So negative x squared minus 4x, and then combine these to make minus 5. So you'll go through the same process, finding your a, b, and c, your axis of symmetry, and vertex. So once you reach the vertex, we solved it to be negative 2, negative 1. And then again, that's where we did that in example number 1 on the previous video. So once you get your vertex, we're ready to go and graph it. So let's go to our graph sheet. We're going to make a table of values and put the center point as our vertex. The vertex is the middle of that parabola, so we're going to put it in the middle of our table. Now we're going to find two numbers less than and two numbers greater than the x value of our table. So two numbers less than and two numbers greater than. So if we have our x value that's a negative 2, we're going to have negative 3 and negative 4, and then greater than that is negative 1 and 0. So at this point we will either calculate the values for y. We can take and plug in this x and solve for y, a lot like we did for the vertex y value, or we can go to our graphing calculator. I always recommend resetting your graphing calculator, especially if you're the first one to use it, or it's the first time you've used it after someone else had. So you might want to jot down to do a calculator reset. It's second memory, which is the plus sign, 712. Second memory, 712. Alright, so on our calculator we're going to press y equals. You'll type in the equation in standard form. So that was where we solved for y. So negative x squared minus 4x minus 5. You'll go second table and scroll up and down until you find the table of values that you need. We need the section from negative 4 to 0. So here, negative 4 to 0, and you'll copy those y values in your table. One thing to notice, we found the vertex to be negative 2, negative 1, so here it is negative 2, negative 1. If ever it's not matching, go back to your y equals and make sure you've typed that function in correctly. It could be just a simple sign error. If we delete out that negative in the front and go second table, notice, look now, our vertex is not working out. So it could be a simple fix in your in the y equals menu. In the y equals menu, make sure that your function is typed in correctly. Alright, so second table, we need those y values. So we have negative 5, negative 2, negative 1, negative 2, and negative 5. So now we're ready to plot those points. By the way, if you'll notice on your handout sheet, this gives you those step-by-step directions on what to push in the calculator to find those tables. So plotting our points, we have -4, -5, -3, -2, -2, -1, -1, -2, and then 0, -5. Of course, always being careful which direction you're traveling when going with your X and Y ordered pair. Connect these with a smooth curved line. It is making that U shape. And now we'll label our axis of symmetry. It's best to use a dashed line because it's not technically part of the graph. So we have that axis of symmetry line. And notice that is at x equals -2. And that's what we solved for in our axis of symmetry work. And then here for our ordered pair for our vertex, that's at -2, -1. Let's take a look at our next example. Number 6. This time we're going to have y equals 2x squared minus 6. So this is the same problem as number 4 from earlier in the previous video. So again, we'll write it in standard form. If you need to write it out, ax squared plus bx plus c. We'll know that our a is 2, our b is 0, and our c is -6. We'll go through the process of our axis of symmetry and our vertex work. And for this problem, we have already solved and found that our vertex for this problem was at 0, -6. So now we're ready to go and graph it. So again, that vertex is in the center of our parabola, so we're going to put in the center of our table. Make yourself 5 places and put that in the center. You'll need 2 numbers less than and 2 numbers greater than that x number. Do not confuse that with the y column. The y column has to be calculated from these x's. So you do not get to come up with your own y values. You either have to calculate them by plugging in these numbers or use the actual calculator. So that's what we're going to go to now. Go back to your y equals menu. Of course, clear out anything that's in there and type in the function that was our standard form. So that 2x squared minus 6. If you want to write in 2x squared plus 0x minus 6, it is the same thing. They will be the same function because it's not necessary to have that plus a 0. But if you need to write that in, feel free to. Press second and then table and scroll up and down until you find the numbers that we needed in our x column. So here, -2 to +2, those are our y values. And if you notice, because we put in that second function, they are the same. So it's not necessary to have both of those if you want to clear those out. So from -2 to 2, copy your y column. So we have a 2, -4, -6. This is always important that your vertex actually matches up. And then -4 and 2. If that vertex is not matching up, you've got some sort of mistake. It could be when you typed it in or in your vertex and axis of symmetry work. So go back and check your work. Now we're going to plot our points. So we have -2, +2, -1, -4, 0, -6, 1, -4, and 2, 2. Of course, connect those points with a smooth curved line. This does make a U shape. Our axis of symmetry is actually the same as this y-axis. When we solved for our axis of symmetry line, we found that x was 0, so that's the same as that y-axis. Our vertex is here at 0, -6. To finish up these problems, let's talk about our domain and range. So going back to number 5, that graph, for those parabolas, I hope you're starting to notice the domain, the x values, is all real numbers. We can continue forever and ever in both directions. So domain, in our interval notation, would be -infinity to infinity. The range of that function, looking at your y-axis, we said that here's our vertex at -1, and it goes below that. So our biggest number we have is +1. The smallest numbers we have are -infinity. And we do put those in least to greatest order, -infinity to 1. Let's look at our other graph for domain and range. For this graph, again, with it being a parabola, we have all real numbers. So it goes from -infinity to infinity. And our range, here our lowest point is at -6. So that's the smallest number. And it stretches on and on and on forever in the positive direction, so that would be +infinity. The -6, since there's a point at that value, we do need a bracket for our range. If you'll also remember, when we talked about our vertex point, we also talked about max and min. So we had said that our vertex for this number 5 had a minimum value, had a maximum value at -1. That comes from the fact that our A was negative. So if you think about our range, here's our maximum value at that 1. So our range has to be smaller than that maximum. Or in the case of our graph for number 6, we said that it had a minimum value at -6. So noticing here's that minimum value, our range has to be greater than that. So our range will look like this when those graphs open up.